Hello, hello. If anybody's out there, let me know if you can hear me. I'm a little bit under the weather, so I don't know how long the stream will last. Good deal. Thanks, Drittal. I think it's Driddle or Drittal. But like I said, I got a little tiny touch of a head cold, and so it's making my nose kind of run and stuff, but ain't got nothing else to do, so work on some amps here. I got an audio pipe, the APDL 1601D. Love these amps. There's a lot of amps, Scar, audio pipe, whole bunch that use this design, and I'll talk about it here in a second. These are fantabulous little entry levels. They do blow, but they're really easy to fix normally. You know, they can be a little bit expensive because you can blow a whole bunch of stuff if you really blow it, but they are somewhat easy to fix. And this one looks like it's at least got a blown power supply. That's soot there, and I can see a blown fat there and there and there. So we'll talk about this for a second. D-Riddle. I got it. D-Riddle. Or Riddle. So you got power coming in. These are the power supply smoothing, or the input filter caps to, you know, help filter from your battery and your alternator and stuff just a little bit there. This amp has two power supply toroid coils, transformers. So from the looks of it, probably 1, 2, 3, and 1, 2, 3. So a bank of 3 and 3 for one, and a bank of 3 and 3 for the other. Don't know which way it is, but doesn't matter. By the way, my face cam is not working, so that's good. I'm in my jammy pants. It's New Year's. Probably the rectifiers, the diodes to rectify it. These are going to be the rail caps, so once the rectifiers rectify coming off the power supply, smooth this out, and then these will be the outputs. Here are voltage regulators to provide the voltage for the drive circuit and stuff. And then this is the little drive circuit. See if I can hold that up there. This is really common. This is the slightly newer version, so it's got two of the 74HC02s in it, I think. That's those two chips. The little chip would be a TL072, and then the bigger chip's going to be like an LM339. That's op-amp for shutdowns and stuff, and comparator. It's a comparator style. So we're going to have to start taking this thing apart because we've already got blown stuff here, so we can get it out of the heat sink. So we can test which FETs are blown. We'll see if we have anything blown in the... Yep, Type 4 Todd. That's Todd at Ellensburg Amplifier Repair and Service. He makes YouTube videos. Check out his videos. He is 100 times smarter than I am. And he's really good at all of them. I like the old school stuff a little more. He's probably a little better at some of these. Of course, he does it for a living. I just do it as a hobby. So if you need your amp fixed, look up Ellensburg Amplifier Repair and send Todd your info, and he will see if it's fixable. I also got a few other friends that are taking stuff in. There's Strictly Amps. I know they're taking some in. GNS Amp Repair. I know he's taking some in. He does lots of Rockford. He's a former Rockford tech, George is, and he also does all the JL Audio Slash. That's who JL Audio is actually recommending send your amp to if you are looking for someone for a JL Slash series, because they no longer repair the Slash series. I like to toot George for that, because he's done such a good job that JL's now recommended him. So that's impressive. If the OEM will recommend you, then that's good. Then there's always Desert Audio for your Rockford stuff and other stuff. In Arizona, there's Freeman's Car Stereo. Jason over there. They are also authorized Rockford. And then like Todd and Strictly Amps, they are, I know, at least authorized Tar Amps. And some other stuff. Whoa, that fit is stuck. Oh, wow. So, there are guys out there, I know, a lot of people recommend, I've never met the gentleman, either one of the gentlemen there at Amp Labs. I know they suspended their taking in of outside stuff due to so many OEM repairs they had, and then I know a bunch of guys that do OEM stuff, and they're not taking anything outside because they've got so many OEM repairs. Parts are hard to come by. Like I said, I've got a little bit of sniffle, so you guys have to pardon me. I'm going to blow my nose several times. But not too bad. I don't feel bad. It just, you know, head cold. So you got a little drainage. So this one's got the goo so much in here. Finally get to see a live stream. Hey, it's Joe. Joe, how is your amp repairs going? I know you've been working on several. I think, if I remember right, you were working on like a 300 or like a one of the big power Fosgates or something. Maybe. Tar Amps and Stetson for Todd over at Ellensburg. So he's doing the Stetson amps. Oh boy. Uh-oh. I can already tell you something. A little vibration damage or something. That resistor's too floppy. It's like it's going to lift right out of there. We're going to have to check that. That may not bode well for this output section. These are not wanting to come up. I need a bigger screwdriver. Sorry if my fat head gets in the way. I hope everybody had a good Christmas, or whatever you celebrate, and I hope everybody's having a good start to their new year. Like I said, I got a head cold, so my New Year's starting a little crappy, but it always works that way. Anytime I get a few days off, that's when I'm going to get a head cold. That's just the way my luck goes. Always on my days off, it seems like, so it makes it harder to get stuff done. And we've got crappy cold weather, so I'm not out cutting tile to finish the bathroom. Alright, we got all the clamps free. Now, this one does have what everybody likes to call the Tiffany style RCAs, so I'm going to try to just take these bolts out. I'm doing this all slow without my power driver. I don't know why, but and slide it this way, hopefully, so that way we don't have to take this end plate off. So Todd said he fixed a scar, and so, you know, a lot of people like to dig on some of the cheaper priced amps, and yes, they are cheaper, and yes, sometimes that can make them unrepairable because they skimp on the circuit board a little bit, maybe on copper thickness or something like that. Things like that. But if you're just, I'm in some groups like Bassheads on a Budget and stuff. If you're just getting into stuff, these audio pipes, scars and stuff, I try to tell people kind of stay away from some of the super cheapos. But these are affordable amps, and they use a common circuit design. They're just building them to a price point, and if you're conservative with it and you don't try to make it produce more than what it should, and you don't wire it too low, and as long as you feed it good power wire and you have got good grounds and everything, you can enjoy adding good bass to anything with one of these amps, and it should last. But a lot of people get them and then they want more, and so they wire them too low, or they don't take the time to prep their car for make sure their power and ground cables are all good and everything, and so they can blow them up. This one may be toast, you never know. It may have cooked the board so bad that it's unrepairable. It happens, but hopefully we'll get lucky and these are just loose and can be fixed, and hopefully it's just the power supply, but we'll test it here in a minute. Alright, that's the end cap off. We have a ground wire right here. You guys can't see that. There's a ground wire here on the case. Kind of different. Normally they're not on the case. Normally they put them on one of the clamps for the heatsink. So let's see. Do we have any bolts in the middle? It does not look it. So now we just need to pop our FETs free, I believe. Just give them a little wiggle, and then normally lean, and then you can lean them out. You're just popping them free from that. It's kind of a silicone. I'd call it a Silpad, but I don't think it's Silpad brand. One we got to worry about is this side where it's cooked. We'll get this thing free. Like I said, just give them a little wiggle and they pop right off. And then you can lean them back just a little so they can slide it out. This side may be something else. Yeah, that FET's falling apart. That one is. These are already popped free because they got so hot. Pieces of the FET falling off everywhere. We've all are sick. Oh yeah, it was Power 300 joke. That's cool, yeah. Because you'd messaged me about it. You were working on the power supply side, if I remember correct. Oh, there it went. Just a little pressure and it popped free. The original FETs had puked. Or you had some. So we'll have to clean all that up if this thing's salvageable. So we know we got blown FETs on that one. I don't know if that feeds that coil. Oh my goodness. All the stuff falling off of it. Let's sweep that up out of the way. I don't need all that extra junk all over me. Let's see. Coil windings are here. Okay, so it does three across. It does it across. So these three and these three power that one, and these three and these three power that one, and then you have rectifiers here and here. So we've popped it on both sides. So the first thing I want to check is the output FETs, and then we're going to have to desolder these because I'm afraid they're broke. That feels like that's broke. So I know Todd likes to go in ohm mode. I just go in diode mode normally. We're just looking for shorts to start out with. So you just go from leg to leg. If you get a beep that goes away real quick, that's fine. That just means it's charging a cap. Alright, so that side didn't beep at us. Those might have survived. Get in here from the top. Those I don't get my fat head in the way. Be really nice if it was just a power supply issue. Somebody may have let their voltage drop a little low due to bad grounds or something. So those may be okay. So let's go back over to this good side of what the FETs, or the side that didn't melt down. And we're just going to test. Well, it's showing a short. So I'm going to assume that that's probably all toast. So those were 3205s. That's what that one is. So they're all going to be that way. So next thing I'm going to do is clean up around this area here to make sure we're not so crispy on the board that it's just unrepairable. And then we also want to look on the bottom. We're going to clean the bottom. So that's just, I got little, you can get these little metal dishes, I think at the dollar store, something like that. Walmart had them. I think that may be where I got them. But just some Q-tips. Although with the amount of goo that was down through there, I wonder if there was a little water that got in on this thing. It may just have been factory flux, you never know. Just wanting to clean it up so we can inspect. I use these eye loops. I also have a little magnifying kind of a microscope. It's a homemade jerry-rigged setup. I don't have a fancy microscope like some electronics repair guys do. One of these days I'll get one maybe. I'd love one that does a real good job anyway. So that's got that cleaned up, and then I just use the 10 times eye loop. I cleaned it up here. Trying to keep track. Yeah, not every board can be fixed. That is correct, Todd. Some of them are baked. You do a better job of the baked ones than I do. But I have a couple baked ones that I'm going to have to work on. Let's see if they can do. So anyway, 10 times eye loop, sorry. So I'll just take it, pick it up. I didn't see anything. What I'm looking for, if I can show you, let me get a pointer here, is looking for these to have broke or burned through on this parts of the trace, on the middle leg there. Normally that's what happens, and then inspecting around the others to make sure it didn't lift up. But normally the top, the rest of it's on the top part of the board. But if you see where it's just completely destroyed that, and it's peeling up, then that's not good. So then we're going to scrub on this. I'm going to assume most of the gate resistors have probably died, maybe some of the clamping diodes and pull down resistors, but we'll clean it up a little here. You can see where when they died, they just spewed stuff everywhere. And you really got to clean this stuff all up. It's even on the power wires there. So a funny thing I've seen in pictures and in some repairs and stuff, some of the other brands of these affordable amplifiers, somebody will open them up and it'll have wires like this on them, and those wires will say audio pipe on them, even though the brand's not audio pipe. It's made in the same place that these audio pipes are. Just audio pipe probably orders so many that they just keep reusing the wire that audio pipe paid for to put their name on. But I have seen that. That tells you how popular this design is. Like I said, budget, good power. It is Class D. It probably does exactly rated. Nothing extra. Oh, Joe, are you cheating on me? Are you contacting Todd too about them problems on that amp? And I'm not your only go-to guy. I'm hurt. Can't you tell? I'm hurt. I'm crushed that you would ask another guy his opinion that's like 10 times smarter than me. No, I hope that 300's coming along. That's be fine, awesome. I keep looking for a Rockford Fosgate Power 300, 600, 650, 1000 that somebody doesn't want to mint a fortune for, that is broken, non-working, because I want to be able to do a man, it's filthy. It blew that stuff everywhere. So that I can do a repair video on it and let people know a little bit about the insides of it. Like I said, I don't ever claim to be an expert on any. There's guys that know amps much better, understand the amp properties. I technically more into industrial electronics. Wow, I think that resistor's even lifted off the board. But it looks like, let me get a little more cleaning here and then I'll hold it up to the camera. Looks like the circuit board survived. We'll know when we get everything out here. And if it's just the power supply, that's pretty affordable repair. Thanks to me buying a butt ton of 3205s at a time, so I can get them somewhat cheap. We'll most likely have to replace the gate resistors. May not have to on this side, but we'll see what size they are. And then we may have to replace here. This is the TL494, which is the pulse width modulation chip. And so it's going to send out the pulses, and they're going to go through, and you can't see them. They're underneath this wire here, but you can see this side's set of transistors. And those transistors are then going to be driving the legs of all the gates of all this through a resistor. And so we may have to replace some of those to get the drive to be correct. Hopefully the TL survived. So let's see. Yeah, no doubt. If you're using the fiberglass filler, it will make you itch all everywhere you get it, because it'll get underneath your skin and be poking. So I'm just going to straight off the bat remove all 6 of those and all 6 of those. So I'm going to fire up the desoldering gun, and it's got the big tip on it right now. I'd like the little tip. There's the little tip. Alright, we're going to let that heat up. And I'll look at chat. Alright, what are we getting, chat? No way that output made it. That's surprising. Well, we haven't tested it yet. I use an old webcam as a microscope, works good. Yes, I have done it. If you watch, that's Tuloco 16. I have used the old webcams, and I've stuck them here through this to magnify with the webcam, and it works. chance, Damon, do you have a 16 gauge blue wire from Phoenix Gold from the early 2000s? I have Phoenix Gold M100 that needs new wire. No, I do not. I'm actually needing to look for some colored wires. I think it was Stinger that made it for a whole bunch of those manufacturers, because like the US amps that I got a couple that I'm going to be fixing. They need some new wire and stuff, and it was gray and purple and stuff like that for the different wires and stuff. And Stinger still makes some of those colors, but they're all branded Stinger, but they look identical. So I think Stinger actually made those and branded them. That's my opinion. Don't take me 100% on that. Stinger would be a good replacement and look good. So I normally do the 2 outside legs. And if they wiggle perfectly from the get-go, then when you do the middle leg, you can just kind of give it all a wiggle, and now it's ready to drop out. But I like to give it a little wiggle while I'm doing it. You see me wiggling it with my finger because that lets that solder all around get sucked up. And then they'll just fall out whenever I'm ready to take them out. Sometimes if you don't give them that little wiggle, they will the solder, like on, if they're leaned a little or whatever, doesn't want to suck up from one side perfectly. And this gets it all the way around and makes it free in the via, and no damage to the via that way. Sometimes you have to go back and redo one, but so if you're learning electronics, I'm trying to talk in between the fart gun noises. Here is how I do it. I take them out in order, and I'll lay them out. And the reason why, whenever I'm taking out components, especially on something I've never worked on or something like that before, notice how these are just dropping out as I wiggle them. Then we can go through and test them, and we know exactly how they came out. Because you may not be working on an amp, you may be working on a power supply for a TV. Which, careful, not only on car stereo amps on the rail voltage side, high voltage. Todd does a good job always warning everybody. Be safe around the rail caps, discharge the rail caps. Same thing applies to mains powered equipment. They can be very, very high voltage, up over 400 volts on the main caps there, depending on their style. And so, sorry, sniffles. I'm gonna have to blow my nose here in a minute. So you can have, make sure you check those and discharge. This thing's been setting for a long time. Plus it has a blown power supply, so not so much of a worry on this one. These are all gonna fall apart. Just crazy goofy. Because legs are going to fall apart like that. But if you're doing that, be careful. High voltage stuff. Learn where that stuff's at. And when you watch YouTube videos to learn how to do something, you need to watch several, because you'll find some that are done by somebody that really didn't understand what they're doing. They just fumbled through and they got lucky and they didn't really do it right, or they didn't do it safe. So watch a couple. You'll find somebody that's good at it, that will give you the warnings of what to do and what not to do to be safe. And that way, when you try those things, you need to be safe. It's like my little disclaimer says, you're responsible for everything you do. And so if you don't take time to learn just enough to be safe, then don't do it, please. Nobody wants to get hurt. Well, that one just fell out. We're going to have to clean up some legs off these. I don't think any of these will need to test. That one actually came out. That one just fell off. Getting ready to do some work on that Rockford 750 BD and shoot the rest of the video. I did some preliminary stuff, and it is, I found this out, some of the guys in some of the repair chats said that, oh man, the FETs were hard to get out, and they are. It's got definitely got a hell of a ground plane in it. Try to get all these legs loose. Okay, where was that? I'm a little space cadet-y. This is for a collector. Todd, on that Phoenix Gold, you might try Jason in our repair groups there. He is the Phoenix Gold master, and he might have some of that. I'm going to go ahead and turn this off. We'll use the soldering iron to heat up the rest of this to clean that up. I do need to put my eye loop in and take a peek. Okay, 47 ohm gate resistors, so that's good. But we're going to go ahead and pull this in. The reason why is we know this side was blown. Was it making a direct short? Yeah, so that's blown. That one's blown. Yep, I told you. I got a little head cold. I'm gonna blow again. Sorry, guys. Don't worry, I will wipe the amplifier down with alcohol, and it's gonna set till sometime. Even if I got it repaired today, it'd be way late next week and before it ever got returned. Because the guy's far away on this. I don't run that. I just can run there in 10 minutes, kind of thing. So I ain't gonna spread my germs to nobody. It'll have set for plenty long enough. So all those blew, and all these are blown. So we can just pick them all up. And that's fine. It's just neat to learn that. The whole point in laying that out is so that you can learn. Sometimes, especially on something that's not as symmetrical as this and everything, that you can learn, okay, that component I took out when I checked it out of circuit, it was the blown one, but these others were not, because that one was showing the short on these others, and you can tell. You get that a lot in the output sections. Just one FET will blow, and it'll show shorted, and so when you pull, start pulling it, it's kind of nice to know that, hey, only one FET actually blew. You may still need to rebuild the drive circuit or whatever, but that means there was less damage. It popped quick enough that that there's a good chance for less damage, stuff like that. It'll explain why the amp blew. Like I said, we don't know 100% why this one died. I mean, obviously, power supply, but these check good. I'm going to check them again. But normally it's something the output blows, and that'll make the power supply run too hard and blow it up. All right, if I can get it around here. I need to find tweezers. Alright, so now I'm just working on taking these legs out. Just get them hot. We've cleaned up most all the solder around them, so we're just getting any of the solder. Clean my tip up a little. Proper tip care is super huge important. This one, boost my heat a little. There we go. Now it's starting to get a little. We just want to gently wiggle them out. We want to save the holes in the pads and the vias. And if you pull and it's not melted the solder, you will rip up pads and you will rip out vias. So always give it a little jiggle and make sure it's coming. Just gentle. Because like that one looks a little rough. This one's already floppy, so we add a little heat to make sure. There we go. Come out, there's part of the broken FET still. We got blowed gate resistors for certain. Then these legs just crisscrossed and went crazy. Yeah, learning how to take care of your soldering iron tips so they last for a long time and they transfer heat really easy. That is a huge thing. Once I learned that, man, my soldering actually got much easier because I keep my tip clean and in good shape. All right, we've got all that out. Turn that off and get a little more rubbing alcohol. And now that we got those out of the way, clean on this pad area a little, where those FETs were. Start to see everything that's going on here. So we got a couple pads. I'll see if I can hold it up to the camera. A couple pads that look like they've seen better days, and then I'll tell you if they're okay or not. Like, I can see one that looked like it's seen better days, but it's going to be okay because it's actually the center trace. And I know from looking at the bottom that actually all the trace is on the bottom on that center leg. And so I'm Just have to make sure we get a high quality solder joint. You can replace some vias. I have some press-in vias and stuff for certain repairs that I have to do. So let's see. I didn't have the wire for Todd. Todd's talking about, yeah, he's working on a home amp. And I know what I was going towards. I try to tell everybody, if you have an interest in electronics and you're going to sit down and really actually learn it and take the time to learn basic electronics and then learn more stuff and learn how to repair stuff, focus on switching power supplies, because they're in everything. Car amps, your TV, your computer, everything. That's always a switching power supply. Your charger for your phone, the charger for your Nintendo Switch. You know, it's all switching power supplies and stuff. And then you can get into these are technically voltage regulated little switchers that charge lithium batteries and stuff. So once you start learning how the different kinds of switching power supplies work, that opens up you being able to fix a lot of stuff. And power supplies die and everything. Lots of TVs get trashed because their switching power supply died, and they didn't have to be trashed. So we have got some nastiness going on there. So we clean up a little and I'll read. For line level repairs, to use a differential probe. I do not have a differential probe. I got a 2-channel, and my old scope had it where you could do math on it, where you could sum and add, and this one does too. It's got add and dual, so on the vertical mode. Some of them have more features. Mine's just a BK precision. It is 100 megahertz, but it's not the best. I'd like to get me a little nicer one. Joe says that Phoenix Gold M100 is a nice amp. I have I think it's an M44 to repair. So I will be doing an old school Phoenix Gold eventually. I've got 3 sound streams. That old school Phoenix Gold, I got 3 linear powers. Let's see, what else? Tons of old Rockfords, some old Kicker, some old Memphis, not super old Memphis, but I got some, what else do I got in there? Those sound streams, I got, US amps, I got 3 of those to repair. These are all mine that'll get repaired. I got an old Pioneer GMH50, which is going to be a fun repair video to do on, because there's fun stories that go with that one. And stuff. So let's see if I'm watching here. If you look, see Q30 right there, that middle leg is kind of divoted down in the middle, and the edges of the pad are up. I don't know if you can tell, but anyway, Q30 goes right into the middle of that pad. So actually the trace is on the bottom. That's just the through hole via and everything. So as long as we're careful on that one, it'll stay there, and we'll have plenty to solder to, but its actual power trace is there. And that's where you're going to notice most things flick off, is when the trace is on the opposite side, so there's not as much to hold it together. Uh-oh. I feel a sneeze coming on. I'm going to be ready for it. Todd says, Joe, I don't get why the M100 used 16 volt input capacitors, which was the failure point of this amplifier. I don't even know what this one's got. Yeah, it's got 25 volt, which is pretty common, but 16 volts pretty common too, or at least on older amps like that, because back in the day, 13.5 was the max you would ever see out of older cars' charging systems. you know, up to 14 volts kind of thing. Nowadays they charge a little higher to try to get a little more current. But that brings us into another problem. A lot of these guys going to lithiums and getting some of the high output alternators and stuff like that are going way high on their voltage, 15.5 volts, and they're actually going too high. Like Rockfords and a whole bunch of other amps will actually shut off if the voltage gets too high. And I need to do a video on that shows that it actually cuts off at low voltage and at high voltage. But the reason why that can be bad is if the amp is maybe on a cheaper amp like this, maybe they didn't put a high voltage cutoff, maybe they only put a low voltage. When you increase the input voltage, it's going to build a bigger rail voltage. And sometimes they skimp on the cap voltage, and they'll be like 80 volt caps, and it'll end up being 155, let's say 156 volt rail to rail thing. So each cap's seeing like 76 volts. And if you raise that input voltage up too much, you start exceeding the rail voltage capacitance, and then that can mean extra wattage to dissipate in the power supply section and everything else. But you're pushing beyond the design limits, and so that's a scary thing if you don't have quality components and don't really know what you're doing. And since it's getting real easy to get some of that stuff, there's guys out there that don't know what they're doing, and they just think, oh, more voltage, that's all I need. More voltage is better, and they don't realize they didn't buy the correct equipment, or they've cranked it up too much and now are shortening the life of their amplifier. And some amps really don't like it. Seems like I want to say some of the full bridge designs don't like it when you go up too high either. I'm not an expert on all those. Maybe Todd knows some of them that are more particular about it. Older tar amps or newer tar amps, or the sound digitals or their clones or something like that. But you know, pay attention to what the manufacturer says the voltage rating is for your amplifier. What's the recommended heat? I have mine in Celsius. So I normally run 300 to 350 on my soldering iron in Celsius. And then on my hot air rework station, it's about 400. That goes up and down. 450 is normally the max you can get out of your hot air, no matter what you buy. But the only reason why I do Celsius is because it ends up being a little easier to know, because most manufacturers of solder and all that crap list Celsius first before they do Fahrenheit. And so when you're looking at data sheets for not only components for baking them, if you're going to reflow them or stuff like that, is you know, they're all made in countries that are not using the American system. So they're going to list that first, and you may have to dig for the Fahrenheit. So it's just easier to match your stuff. And almost every modern hot air rework station and soldering iron allows you to switch between Fahrenheit and Celsius. So, you know, depending, it's just easy to swap it, and then you can just look at that. So what is that Fahrenheit? I don't know, probably 700, 650, something like that. I don't know. But be careful on your heat. As you get good learning to maintain your soldering iron tips and stuff like that, you'll learn that you can use extra heat. Once you know what you're doing and know how to properly heat a pad and not damage it, and that comes with, you know, just time and experience. But you can actually use a little extra heat once you get good at it and understand what that's doing, to be able to actually put less heat in the board overall, because you will be heating that one little area and getting it removed and removing it quickly and letting it cool back down, instead of sometimes at a lower temperature you end up heat soaking if that certain thing that you're soldering happens to wick away heat a lot. And so sometimes you'll find those things, and you'll need to crank up your heat a little bit so that you can get that one spot desoldered and get it back off there, instead of letting a lower temperature sit there and soak for so long and so much heat spreading out to the rest of the board. And that all depends on the board. You know, it's copper thicknesses and all that other stuff, and so some of it's learned by feel. Yeah, 300C equals 572. Thanks, Joe, for putting that up there. So I'm a little off on my math in my head. My excuse is I get a head cold. El Fuego is learning, yeah. I have an ADS power plate 120 that's giving me a headache. I've got one ADS amp. It's a power plate, but it's the little bitty tiny chip amp one. I've got a couple different little amps like that are little chip amps that were from back in the day. I think a Pluto. I don't have the Pluto, but the Hyphonics Pluto I think was one of the little tiny ADS power plates was and stuff. They were tiny little chip amps that were kind of designed for just replacing your factory stereo's power. They gave you actually good, clean RMS power instead of what your head unit could give you for people that just wanted replacement and it to sound decent. So they were fun, and they're great for running tweeters and stuff like that. But I've got a whole little segment that I'll eventually one day do. That is those little chip amp setups, if I ever get to it. Nice, great videos coming up. Yep, keeps us in business. The IRF 3205 gate resistor suggestions. That's easy. Normally it's 47 ohm. I've seen as low as like 22 ohm. And as high as like, I'm trying to look up here. I think you can go as high as like about 60 ohm, but almost every amp I've ever seen that actually uses them in it uses a 47 ohm. Like I said, I've seen them come down to 22 ohm. But a little bit of that depends on the drive circuit and how many you're driving. But almost 99.9% of the time, 47 ohm. That's what's on here, and that's what we'll be replacing here. Here comes that sneeze. So the last thing on your soldering iron is how powerful it is. And on these digital ones, like that I'm using, these KSG-ERs, that'll determine how fast they can recover heat. So that when you go to put heat in, they can ramp up and keep that heat on there so that you can desolder stuff quickly. So we have 47 to 47. These are 103 for the pull down resistors. So that's one of these is going to be that. That's going to be that one and that one. So we need to check those two. So 103 is going to be 10K. So I'm going to put my meter on 20K. And we're going to check. Oh, you guys can't see that. So we should get a reading of 90 on that one. And this one's still got some dirt on it. That don't seem right. 6.9. Yep. Not cool. If we turn it down, we should get... We ain't going to get any reading on this one. That's just toast. That's one of the 47 ohm gate resistors. That one may just be totally burnt up. 47 there. 47-ish there. Sorry, like I said, a little under the weather, so we are going to get a little flux and put it on the, let me show you that resistor, how bad that one is before if I can get it to focus. It's come up, its pads may even be wrecked. It may have just blown in two, I'm not sure. But we're going to get a little flux on there. My flux is cold. It's a little chilly out in the garage. Little flux. And I'm just taking them all off here. all the gate resistors anyway. The one pull down there and that pull down seemed okay, but I may replace those on this side, and then we'll go over and check the other side. I'm also going to get a little solder braid over here and snip the end off. And really, all I'm concerned about, there's a place where a thermal would have been. I don't see any thermal protection in this amp. There's labeled for it, but doesn't seem to have it. So I got my big wide tip. Oh, I should have showed you that before I cleaned it, and then that's after I cleaned it, and it gets all nice and shiny. Because we're going to be removing surface mount stuff. And I'm just going to add some solder, clean it again, and then add a little bit of solder. And so then I can work on both sides. Oh, and I need my tweezers here. I can work on both sides of the resistor and just get it to slide out of the way and then off. And just slides them right off on these little surface mounts. And yes, I could save some of these 47 ohms resistors probably, but I always just the ones I buy are at least 1% tolerance, and so I don't know how good or bad the factory ones were, so I just, out of abundance of caution, replace them all if they've been abused. Hey, that one was busted in two pieces. We need a little more solder. This one's definitely fried. It's got a hole in the middle. A little more solder on there. The reason why we do that with flux is that it helps clean, and whenever one gets fried like this, it'll help a little bit of this leaded solder bond, because we don't want to damage the pads. We're hoping there we go, to get it to pop off without damaging the pads. And clean up your soldering iron, and then go over it with a little of your braid. Should clean up nice. That one pad, this has still got part of the resistor on it, so it did come apart. So I add a little. There we go. I'm just knocking them off my soldering iron here. And just give it a good swipe. We're looking for nice, clean pads. And then you can also do that on where the fets go to clean them up. Make sure you got some flux on there. This one needs a little. That one may need it from the other side. We need to snip off a little of the end here. Get rid of some of that completely soaked through. That looks good. And I'm going to go on this one that is the pull down. I'm going to add a tiny bit more flux. Clean up our soldering iron. We're just going to hit one side, we're going to let set. on the other side, so we can make sure we get a good reading, because that one was where that other resistor completely blew up and it had a whole bunch of junk, and I just want to take a reading on it. So I've left the two pull down resistors, which are supposed to be 10K, in there, and we want to take a reading on those. We can replace them a lot of times. Sometimes you have to. A lot of times they survive, but not always. So I've got me a little apple cider here. I'm going to get a drink. All right, let's see what chat says. 33 to 68 ohms, depending on the drive topology. See, Todd says so too. 47's right in the middle there. Beautiful. Jordan says, I got a Rockford Fosgate T1001 BD that's giving me a fit. No output FETs installed. The power supply drive looks fine on initial power out, but once it kicks in the audio circuit, I got a lot of noise on the power supply drive and all the op amps. Yeah, Todd says it may be looking for feedback. Also, if that's the 30 or the, what is it, the 3525 or the 3526, a lot of those can be used in regulated style, and so once they build rail voltage, they'll look really goofy because they're just kind of doing a little quick weird pulse, and it shows up weird on your scope. It'll look like a standard square wave when it's first building rail voltage up, but once it gets built, then it just shows a crazy little wave, because it's doing no work, so it's just keeping the rail voltage built up. Sometimes that can be it, but it also depends. I use, if you look over here, I've got a power supply, if you look there, that has current on it, and so I can, like when we go to power this one up and check here in a minute, if we see irregular power, we know there's something might be damaged in this circuit, because it shouldn't be powering anything else over here, because we're not developing anything there. So that's another thing. The fact that it's making a dirty audio signal worries me, that you do have something in its plus and minus 12 to 15 volts for the op amp and stuff. And since it's a BD, I believe he said, it also has other voltages in there that drive the BD circuit. Those amps are, unless you really know what you're doing, I do not recommend learning on any of the Rockford Fosgate BD amps, because they are very unique and very tricky, and they have a lot of extra voltages and extra things that are going on, and that's the hardest amps to learn to repair when you're first getting into all this. Hey, Hi-Fi's in the house. Glad to see you, man. I'll be listening to him doing some testing himself. Well, that's good. Jordan's soldering in some 40 ohm, 7 ohm resistors on a US amps. Merlin. So that's the Merlin, I think, is kind of the what I'd call their midpoint. It's not their old school stuff. Everything I got's their old school. One of them's actually super old school. It's got a instead of having a TL chip in it, it's self-oscillating, which is like some of the very first series of the punch amps and stuff. And I love learning about that older stuff like that. Oh, Todd, you got in some 3005s. Did you get a few extras for a feller? Mine were supposed to be on October 9th, and they still haven't showed up. And I need like 12. So I'm waiting patiently, but I still have not got them. Yep. Yep. Tukalo 16, always adding leaded leaded solder, because modern stuff's made with lead-free solder, which has a higher melting temperature. This will lower down the melting temperature. Super important when you're doing surface mount work and you're using hot air. If you'll go in with your soldering iron before and you add the leaded solder to all the joints kind of going around it, even if it's a big chip and you're just running that down, then when you go with your hot air, it will melt and you can lift it with your tweezers before the others actually will. And so you won't blow them away. Lots and lots of people, when they're first learning to use hot air, get everything full temperature that melts all the solder all in that area, and then they blow little caps and little resistors and stuff all the way. And then they're like, uh-oh. And it makes for a whole bunch of stuff. Yeah, the BDs and the JLs are not for beginners. Exactly, Todd. Jordan says it is a 3626. So it may be self-regulating there. The JLs do that also once they've built it up. So what you have to do is have the rail caps completely discharged. Have your probe on there, and when you first fire it up, be watching the scope. And if it makes a perfect square wave to start out, and then you can have your meter hooked up to watch the rail voltage. When you see the rail voltage gets close, if it starts changing, that means it's just topping it off because you're not loading up anything else. I got a funny feeling on your BD you've got other problems in the other regulators that drive its circuit. Like I said, Rockford's BD took a whole lot for me to wrap my head around, just because of half the outputs are switchers that switch the rail voltage up and down, and the other half are the actually outputs, which is really cool. I'm waiting for Todd to chime in on his on if he got a whole bunch of those 3005s. He may not do it in the chat. Maybe he'll text me and tell me he's got a whole bunch, or maybe he'll text me and tell me he got exactly the right amount because he had to pay an outrageous price for them. I know there was one website that was selling them for like 2,000% markup, something crazy like that. Yeah, Tuklo was talking about output coils and stuff. One thing you always need to do, and stuff like that right there, that leg's not cool. See how it wiggles? That could have a short underneath it. That could have been the cause of this thing's death. But you need to wiggle the transformers and make sure they're seated, and then you need to be checking like that wire. See how they're depending on that little tiny bit of glue to keep that from wiggling around. Same with this. Now this has got a sleeve on it, so that is helping it, so it shouldn't rub the insulation, but you gotta watch out for that stuff. And then wiggling your output transformers, because a lot of them don't get glued down correctly, and they get a little vibration, and they either break legs or they rub together and short, and so you always are poking on it. And this one, not my favorite. It's got a lot of stuff that's kind of wiggly, but this is a budget amp built to a price point. I will probably add a little mastic on there. As a matter of fact, I can get my glasses down. That thing moves a whole lot. See how far I can move it over to the side? And then you can look underneath there and make sure it hasn't rubbed through. But we'll end up putting some E6000. I'll run another tiny little ring, and then maybe a little ring on the middle. Don't overdo it, because this needs to cool. You'll find in some older Rockfords where they coated the power transformers, and because that amp runs hot and everything, and it makes a lot of power. I got an 801S that I'll show, and it looks like the power transformer is cooked, and when I first got it, that's what I thought, but it was actually fine. It's that the coating that they put on there just discolors and looks like it cooked over time with the heating and cooling, and so it just looks bad. So okay, need to be doing actual work. Nobody wants to just listen to me blather. I don't know how long I've been going here. I've been live for an hour and 11, so we're going to cut it off here shortly, and I may do another one either late tonight or tomorrow to so I can get a little rest. I don't want to get beat down. What we're just doing is cleaning up our flux, getting this board cleaned up. But yeah, I love the old school stuff. I got a whole stack of amps like this I need to get through and stuff. I'm getting closer to getting all the amps that are not mine, that are buddies and stuff done, so I can get to some of these old school amps that I enjoy, and so I'll be making some videos of that. Just been working so much that's kind of hard to do. Plus, I'm trying to tile our shower surround. My wife would really like me to get that done, but like I said, I'm a little under the weather, and it's nasty out today, so can't really get out and cut tile in the freezing rain. And so, all right, that's all looking much better. So we're going to test one more time on the 20K. Now that we've cleaned up those solder joints. 6.9 and 8.9. There is another one over here. It's reading 1.6. That's not cool. And the other pull down is right there. And it's reading short. So we're going to have to replace all the pull downs. Now, like I said, I like to leave them in, even though now I know I'm going to replace them, so I know they're not the gates. That way I don't have to. You can always figure out which resistor pad is the gate. You can go to the gate leg and find out, so you know. But I'm going to have to look those up. So they're kind of toast. As a matter of fact, I'm really kind of wanting to pull them off now, and all these over here, because I'd really like to, before we get this live stream done, to show you guys the drives. So let's just go ahead and fire up the old soldering iron and pull them. I know they're 10K. I know where they go. But like I said, however, if you're learning to do this, if you're practicing on a junker amp, sometimes you leave even bad components until you have the good component in your hand. I need more solder. There it is. So we get some solder on here. Alright, that is off. And I can almost guarantee that with the damage done to these, that we're not going to get a good drive signal out here on the pads. And then I'll show you where you can look for your good drive signal on the chip. So I'm going to go, we're going to have to get a little bit of flux on these, because I want these to come off clean. Flux, flux, flux. All the time flux. Flux is your friend. Makes things solder up well. It cleans as it takes it off, but it is just going to make everything much better. Especially when you have burnt components. It'll help clean up the area there so that you can get some of this leaded solder on there sometimes. Because we want everything to come off and leave the pads intact. Like that one's not wanting to come off very well. Sorry if my big fat head is in the way. I also need to clean up that pad right there. There we go. See if I can get these to pop off. I have to just spin it all the way around. Get it closer to me. Soldering iron was screaming at me that it's been on for a long time. It's one thing I like about these. That one's off. modern soldering irons, digital and stuff, they'll tell you they've been on a long time. We're just removing. Now, your pull-down resistors can have a different reading than what their actual face value is if they're all in parallel, which a lot of times they are, but you should read the same across all of them, and we're reading all kinds of wild and craziness here. So we're just going to replace them. Little resistors, if you buy them, you know, in a roll, not even a full roll, but you know, they should be a penny a piece kind of thing. I've seen them more expensive. I mean, well, I guess actually 3 cents a piece or something like that, but you'll get, like, I accidentally touched that pad with my soldering iron and it filled it with solder. And so that's why we get a little solder wick here. Go ahead and clean that up while I'm thinking about it. Opens that back up, so that's good. This one's not wanting to come off very well. Oh, we need a little solder. Got that one off. See how these have cooked themselves on when they went bad. That's why I'm taking the time to try to get them off carefully. I don't want to take the pads with it. That one came off finally. This one looks like it's about to come off. Hopefully it's not taking the pad. It feels like it's taking the pad. It's so burnt. I got it back down, I think. That one finally came off. So, you have to pay attention when you think one's taking a pad off so that you drag it in the right direction and don't rip that pad to shreds. We're just going to be real careful. I'm going to have to blow my nose again. I'm sorry, guys. Nobody wanted to watch a live stream of a dude with a sniffle, did they? Oh. Jordan says that his drive looks exactly what it does, like we described, where it goes full square and then it goes to regulated. So, yeah. That 30 series chips, they're normally used in regulated, where the TL494s are not. Although you can make these semi-regulated or somewhat regulated. Got 7 left of the 10 I ordered from, I was at Raw Material Spot, but I do have an order of 100 that will be in next week. If that order of 100, did you order them from Mauser? Because Mauser's the one that's not got them for me. And mine were due October 7th, I think it was. There, Todd. I had a Class D MTX, the amp doing something similar, tracked it down to the output coil. Yeah, we talked about coils. Not a problem, Jordan. Mark Roberts. Hello, love your videos. Well, thank you, Mark. I've learned so much from them. Well, I'm learning too as I go. Like I said, I'm not an expert. I just know a bit about stuff. And so I'm trying to increase my knowledge. Hey, there's David. Happy New Year just to you, David. Hope you've got your amps up and running. Oh, Todd says he's running. Have a good one, Todd. Be safe in the new year. Jordan's asking about the IRS 2092. No, those are just like the 3005s and a whole bunch of other things that just they're going to be in stock probably midway through this year, maybe if we're all lucky, you know, as they catch up. There's just so much stuff that's out of stock right now, and it makes it hard. The OEMs are sucking it up to build new. The OEMs are sucking it up to send to their authorized repair centers, and that's just how it is. That leaves the rest of us that order normally to have to wait. Alright, so I've got a couple pads that are in rough looking shape. We're going to clean them and inspect them and see if they can be cleaned up anymore, but I'm just touching them with a soldering iron. So let's get it clean. I'll show you what I mean by rough. You see that one and then that one are a bit rough, and this one down at the end. So we want to, and this is just 91% isopropyl alcohol. That is the lowest percentage. If you can get higher, that's better. Don't use the 70% stuff. It's too much water. We're going to start cleaning this up, and I'll do an inspection with my eye loop. Yeah, there's a pad that broke in half. That's what happens there. I can see one that's cracked right there too. You know, when you blow stuff, it does damage to parts of the circuit board, and so we'll have to see where that trace is running and make sure that it's adequate. You got to be real careful with your cotton swabs when you're around damaged traces. You don't want to snag it and pull it up. So just take your time and feel. I've got a handful of those chips, Jordan, but they're already spoken for into amps that are due for repair. That's my whole problem is I've got just enough parts to fix a couple, and then I'm just going to be poop out of luck because I'll be waiting like everybody else. I just got lucky and I happen to have a few in my parts box. Alright, all those gate resistors and junk that were all trashed, we'll get those out of here. So I'll show you that one that right here where my thumb is. See how it cracked in half and just flaked off there. So we get the eye loop and look at these pads. Yeah, they're half ate away. I dare not do too much work to them. Got a little plastic spudger here just to make sure. The one thing you're looking for is whether or not circuit board is broke underneath it. So, and then making sure that they're still good. So like this one, that one works. This one, yep, that one works. And these two should be at the same point. Yep, they are. This one should go to that pad, and then that one that's a little rough is there. And those were all three on the gate resistors, so that's where that, you know, this side blew, but this side actually blew too. So we've got all those removed. Now the worst thing that can happen is that some of the drive transistors that are after this TL494 are dead, and they're not giving us a good drive. So we take our end plate here, and we notice it would normally be on here like this. That tells us 12 volts goes here. So we're going to add some power. Like Bearvids or Todd, they use low power, like 12 volt, looks like laptop supplies. I use my regulated supply up here that's current limited. Either one of those works. Nice, good low power stuff, so that if something is wrong, it'll current limit, and we're going to clean up our mess so that nothing's touching anything. So we've got power, ground. Let me bring up, there's my power supply. So we're going to turn the power supply on, and the scope. We'll let the scope warm up for a minute, and I'll read chat. And then when the scope's ready, we will see if we got some drive out here on the gate pads. It'll be on the pad that, like right, this one goes to the leg right there. So we're going to be looking on that pad. See if I can show that a little better. If I hold this very carefully. So this pad goes to that gate, so we're going to be testing on the other pad since the resistor has been removed. And so we'll adjust the position here a little. We'll get our scope out. And I've got my foot switch rigged up to turn this thing on. I don't know if this has yeah, it's got power and protect lights down there. But we're just going to pulse. And you notice, so I idle at very little, and that's hardly anything coming on. We're just going to look. I don't think we have anything, because we turned up so little. Nothing there. So it doesn't look like we have anything over there. Nothing. So the TL494, somewhere I have a little card. That's my cheat sheet. Because I can't ever remember. It's like legs 9 and 10 or something like that. You can pull up the data sheet also. There we go. It's all dirty. But there's my TL494. And so the outputs are going to be 9 and 10. So that's going to be this right here. Nothing. And nothing. So now we're going to have to look at the chip to see if it's getting power. It's getting absolutely nothing out. So it may be in a protect mode. Oh, I didn't look. We're not getting a protect light or nothing. But we may be dead. We may not be getting anything there. But we're going to go put it on 20 volts. And so we got very important things to do here. We're going to check. Yes, my power supply is putting out 13.52. So then we're going to check on the remote wire. When I hit the switch, yes, we get remote. So now leaving that probe on there. If we look at our cheat sheet, our VCC pin is number 12. I don't know if you can see that. I wrote that down. VCC is the power in. So we're going to go 9, 10, 11, 12. I'm going to put this on 12. And then I'm going to hit the stuff, and I'm not getting power to that chip. Awesome. So something else has died, probably in the remote turn-on circuit. I do not have a schematic for this amp, so what I'm going to do is take a break, and then I will make a video. I'm going to draw this out. I'll turn off my power here. Exactly what I'm going to do is I'm going to trace it from here, the remote turn-on. It's going to probably come through a transistor or two and feed the power to this chip. Once that's repaired, and I want to draw this out because I think it'll make a good video, because when you have problems like this seems to be tough for guys, because now it's going through all this stuff to turn this chip on. We'll figure out what it is, and this should help a whole bunch of people on this style of amp, which is, like I said, Scar, Shark, Audio Pipe, just all those generic up to 2,000 watt amps use this design. And so the board designation numbers may change, but the circuit layout will be the same. And so that's going to be excellent. We'll get 12 volt power to here in a video. I'll make a short video hopefully out of it. I'll have everything drawn up and then show power getting to that. Then we'll see if we actually get drive circuit out of it and then out to these pads. Of course, the TL494 was showing a little bit of tiny leakage voltage on it. It may be bad. May have to replace it. That may be the whole problem on this, but I got to make sure that I'm getting 12 volts up to it, and so I'm going to do it that way. On this little live stream video, if you have any other questions, this would be perfect. Put them in, in the next few days while I'm drawing this out, because I'll probably work on it later tonight after I get some food and a little rest. Start drawing this out. I will look at those comments, and I'll try to include any answers to any questions you might have while I'm doing that little part. And anything else that's on this, and anything else in general. I totally appreciate it. Let's see. Let's finish up chat. The 150 HD is up and running, David says. Good deal, and running great. And that PIM board that you make is so nice. Yes, I actually had to make a bunch more. They have been moving like hotcakes. As word spreads that that I make replacement boards for those, that amp is suddenly worth something again. And so they're stout little amps. Everybody loved them back in the day. And so, yeah, I've been getting a lot of requests for those, and so everybody's bringing those things back to life. And hopefully in some of the Facebook groups that do old school car audio, we'll see a bunch of those installed. I know I got a 150 HD that I'm going to finish up for myself, and then I'm going to put it in my truck to run my subs, and that's going to be great. So awesome to hear, David. And then Jordan says, thank you, no worries. I only need the 2092s for personal amps. Yeah. Like I said, if I can, as soon as they come back in stock, everybody and their brother is going to buy, a bunch just to have them on hand, because we're so worried about the production being crappy for so long. So I am going to get out of here for now. I'm ready to sneeze again. I truly appreciate it. We still have to get back on the back of this and see what all's wrong back here, but I want to draw this out because I've got one pretty good video on talking about these chips where I drew out the circuit on how the transistors work, but this one slightly unique. We're not getting power all the way up to the chip, so either the chip's bad and pulling it down, or we have a problem in the turn-on circuit, and I'd like to draw that turn-on circuit out. Just it's not going to be the same for every amp out there, but it'll give you an idea of how that turn-on circuit works. And that way, hopefully, some people can troubleshoot it. Because I fixed a Kenwood amp. That was the only thing that was wrong with the whole amp, was the turn-on circuit had died, and it was an old style that had I don't have one here available, but it had regular transistors, not surface mount, but through hole, and it ended up being one transistor that was bad that was not allowing it to turn on the remote circuit to turn on the chip to power it up, and that fixed that whole amp. And so it happens from time to time. And so this will be a great one to make a short little video. I'll try to make sure it has this live stream follow-up. And I thank everybody for watching, and thanks for all the questions. And like I said, if I get that done quick enough, I may even throw it a live stream, but I may just shoot a video specifically for it, get it fixed, and then we'll move on, because I want to address those and what I want to do. If I do it in a live stream or whatever, also remind me. I want to point out, see if we can figure out which one of these two, if not both of them, because we got, looks like a single wire and a single wire, that are making the auxiliary voltages, because that's important when you're doing a repair. Sometimes you can power up just one transformer. So if it's that set or that set, because it's the important one, because it's got the auxiliary windings that make your secondary voltages, and you don't even have to power up the other one, so you can save some time for troubleshooting and the risk of exploding components and stuff when you're learning and everything. And so that's important. Like I said, guys, I'm rambling, and I really need to get. And I totally appreciate everybody watching. Hope you learned a little something. Like, comment, subscribe, especially comment if you get any questions. And have a safe and happy New Year's, and wish you all the best. Thanks a bunch for watching.